Well, it's been quite a journey. We have built in C a whole object-oriented pattern, reviewed all of object-oriented programming, implemented a number of different Python objects in C as a way to understand how C++ works, how Java works, how Python works, how they all work under the covers. And so we come to the end of this sort of walk through all these amazing data structures, and I hope you've had fun. But one of the things I like to do at the end is I like to go back to the beginning. So some of you have been with me from the very beginning. Python for Everybody may be the first programming class that you ever took. And I want to now finish by reviewing the very first program that I ever showed you in Python for Everybody. It is from chapter 1. I love this example, and this is counting the most common word in a file. So it's in Python. We read a file name, we create a dictionary, we read all the lines, we split it. I think we don't do conversion to lowercase, but then we're going through all the words, and we're saying we're going to set the counts to counts.get word comma 0. Remember when you first saw that, 0 is the default, and then we're going to add 1, and that's the way when we see the first word, we sort of bootstrap whatever the word is that we're looking at. Then we have a max loop, so we're going to iterate with items. We're going to look for word comma count in items, and we're going to do a simple max loop, and then when it's all done, we're going to print out the largest word and the count of the number of times that large word was shown. So fast forward. Here we go. Now you by now have built a tree map, hopefully. And so now what we're going to do is we're going to use your tree map code, and we're going to implement this count. So we're going to have a tree map, call the constructor for it. That's our dictionary. We're going to have the tree map entry that we're going to need to use to go through the iterator. We're going to have a tree map iterator. We're going to create, because we don't have strings, we're going to create a 100 item array name, char array, and word. And yes, it's dangerous. We're just not going to be too mean to our code and blow it up, but we could. And then variables like I and j and count max value and char max key. That's all of our setup stuff. So we're going to open the file name using scanf. Now we're in C. It's not Python anymore. But you can see the similarity. So then we're going to do an fopen of the file using read. And again, you can see the similarity. We're going to do a scanf through fscanf with a file pointer. And we're going to do a %s, which gives us a word. And word there is a pass by reference, because remember, word's an array. If we don't get an end of file, we're going to write a for loop to go through word and call tolower, which is in ctype.h. And then we are going to carefully put a new line at the end of word. And then we're going to get the current count with map get. Ask for map, which is like self. Word is the key, and 0 is the default. And then we're going to do a map put into the word position with count plus 1. And then we're going to close it, or close the thing, and we're going to dump the map. Then what we're going to do is write a max loop. Max key equals null, max value equals -1. It's a count, so I guess we can assume that -1 works here, because there's only positive integers in our dictionary / tree map. We're going to ask for an iterator. We're going to create an infinite loop. We're going to ask for the next item from the iterator. If it's null, we're done. And if max key is null, or the cur value is greater than or equal to max value, the one we're looking at is greater than our current max, we retain max key and max value. And when we're done, we give back the iterator, and we print out the max key and the max value, and then we delete the map. And so that's the miles to go before I sleep. Been a long time, but the end is really the beginning. These are the most basic data structures. These are the classic data structures. These are the data structures from chapter 6 of Kernighan and Ritchie. These are the data structures for 40 plus years that people have been learning about. Once you get good, and I hope you have taken the time to get really good at these data structures, because what these are is they're like the omelet of cooking. They're easy. It seems like everyone knows how to do them, but until you know how to do the easy stuff, you can't understand the large, fancy stuff. In a recipe, you need foundational notions, and you can create something amazing. If you have done all the work in this course and you've done it well, your journey can continue with many great cookbooks. The one I'm showing you now is what we called CLR, because of the authors. When I did it back in grad school, there was only 3 authors, not 4 authors. CLR, and this is a thick book, a very thick book. And what you're going to find is this is a very well-written book. And if you know everything in this course, you should be able to open this book up to Warshell's algorithm and write an implementation of C, of Warshell's algorithm. Because you know how to allocate things, you know how to create structures with pointers in them, and you know how to deallocate them. And if you learned every lesson in this course, you can almost open anywhere, alpha, beta pruning, all kinds of things. You can just open it up and go 4 or 5 pages, look at how they describe the algorithm, and then implement it. So I'm not going to teach you every one of the algorithms in this book. What I've taught you is what an algorithm is and what the foundational pieces of all algorithms are. Okay? So I wish you luck, and I encourage you to keep going on your journey. Your journey is not ending, it's beginning.